For question 60, we again have another graph. And remember, to make our life a lot easier, we analyze the graph and interpret it before we read the question. So we have our basic tool, Oyzerga, Oyxirga. And the origin we see is a normal origin, quadrant 1, quadrant 2, 3, and 4 like this. So nothing strange there. The y-axis is acceleration in normal units, and the x-axis is time in normal units. And now we look at the intercepts. So we have this intercept here. So a0, the acceleration at time 0 is 4. It is the maximum. And we have this other intercept, this x-intercept down here, where the acceleration is 0. So those are our two intercepts. So what we see happening with the acceleration is the acceleration decreases to 0. So those are our intercepts. What can we read from the graph? Well, we can read acceleration in time, and we've already just described what's happening with the acceleration. It starts at a maximum of 4 and decreases to 0. The gradient is dividing the axes, delta A over delta T, which is the definition of jerk. And what we can see about the jerk in this case is that it's constant and it's negative. The slope is negative and it's constant. So if we were to diagram out what we have happening here is that we have, let's say, our positive direction and negative direction. We've got an object that is experiencing positive acceleration, but the jerk is in the opposite direction, a negative jerk. The area, which we see is acceleration times time. We multiply the axes, meters per second squared times seconds, gives us meters per second. And that meters per second then is the change in velocity. So the change in velocity. And if we look at what's happening then with the area, we can see during this interval time we have this area. And then over the next interval of time, there's less area, but a total area, but less was added. And then in the next equal amount of time, we again add area. The velocity changes more, but it's less than it was previously. And lastly, we have another period of time, and again, we add positive area, but it was less than it was the previous amount of time. So what we see happening then for the area, the change in velocity, is the change in velocity increases at a decreasing rate. So we're adding a certain amount, and then in the next same interval of time, we add more, but it's less. We add more, but it's less. We add more, but it's less. So now when we read the question, it should be very easy for us to answer. Which of the following is the change in velocity of the object at the time interval 0 to 4? Change in velocity, we already know, is the area. So the area of 0 to 4 is the total of those, and that is in the shape of a triangle. So 1/2 base times height. The base is 4 and the height is 4. So 1/2 of 4 is 2 times 4 is 8. So we look for 8, and we notice then that we see there's a positive and a negative. And so we go back to our calculation and we see the height. The acceleration was positive 4 and the base was positive 4. So this area should be positive 8. Also, looking up on the graph, we can see we're in quadrant 1, so all the area in quadrant 1 would be positive. So we're left with choice D.